All right, so let's watch the Jeremy Howard demo, and then we're going to watch the Fireship version of it.
But instead of telling
All right, by the way, we're learning about Mojo, the brand new, super sexy, very exciting programming language that apparently is like 900,000 times faster than Python. What kind of bullshit measurement are they doing? How much do you want to bet they're just like sitting in a for loop for one and for loop for the other and be like, look, see, Python was terrible at loops. Of course Python's terrible at loops. Everybody knows Python's terrible at loops.
you all this now, I'd love to introduce Jeremy Howard, who will show you how Mojo works in practice.
All right, show me, Jeremy. Wow, that person.
Thanks, Chris.
Yeah.
You know, I realized it's been 30 years since I first trained a neural network. And to be honest, I haven't been that satisfied with any of the languages that I've been able to use throughout that time.
I don't think this guy realizes, okay, so he's over there not being satisfied, but little does he even know, if you go to github.com, the Primogen, you will see the beginning of my masters, okay, years ago, back when I was the shittiest programmer in the world. If you go there and you look at my suppositories, you will be able to find everyone's favorite, is it Neural.js? Yeah. I created a trainable network. Okay, look at that. Okay, you see ANFIZ in there? Do you not see that? Look at that. Look at that. We got ANFIZ, Adaptive Neural Fuzzy Inference Systems, okay? Particle Swarm Optimizations and Colony Optimizations, Competitive Clustering, okay? We probably got some RBFs in there, Radial Basis Functions. See, I didn't even know. See, here's the deal. I did this a decade ago, and I didn't know that JavaScript was going to be used for everything. Think if I would have known that the world was being rewritten in... Okay, I didn't know, okay? I was brand new. I was a baby. Let me be a baby, okay? I was a baby, and Jeremy would have been proud of me.
In fact, I complained to Chris about this when I first met him years ago. And Chris has been telling me ever since, don't worry, Jeremy, one day we are going to fix this. The thing that I really want to fix is to see a language where I can write performant, flexible, hardcore code, but it should also be concise.
A lot of young men all about that hardcore coding, okay? I've heard about it. I've seen it on this, okay? I've seen this. I've seen this on the internet. There's some posts, and it makes me feel really uncomfortable. I don't like it. I don't like it. I don't like it, okay? Can we just go back to standard softcore JavaScript programming? That's all I want to see, okay? This is inappropriate, all right?
Readable, understandable code. And I think that actually Chris and his team here have done it with this new language called Mojo. Mojo is actually a superset of Python, so I can use my Python code. Here.
Did you just hear that? Okay, so I didn't see that one coming. The fact that you can just use your Python, that might actually make this a very sellable language then, right? If you could, theoretically, if you could instantaneously have your code be faster and just write Python. That's a lie? Okay, that is a lie. Okay, just checking.
Check this out. I'll show you what I mean.
Okay.
So here is a notebook, right?
Yeah.
But this notebook is no normal notebook. This is a
Yeah, I can see because there's a % sign, then the word Python, which makes me feel strange on the inside.
Mojo notebook. And
Ooh, a Mojo
by
notebook.
way of...
By the way, does anyone think of Austin Powers? Like right now, that's all I keep hearing is Austin Powers in my head. And I can't get it out.
Demonstration, because this is the most fundamental foundational algorithm in deep learning, we're going to look at matrix multiplication. Now, of course, Mojo's got its own. We don't need to write our own, but we're just showing you we can actually write our own high performance matrix multiplication.
Isn't there like a better version of matrix multiplication? Right? Isn't there some new one that's come out that's not like this? Isn't there some sort of sweet algorithm that somebody made? Anyways.
Let's start by comparing to Python. That's very easy to do.
There is,
just type
yeah.
%Python in a...
And also, I assume there must be, is there some sweet SIMD operations that can be done with reading a bunch of data and then making only a singular multiplication? I don't know how any of this stuff, I don't know how this stuff works. I have no idea. I'm not a machine level enthusiast. I'm too stupid for it, okay?
And then it actually is going to run it on the CPython interpreter. So here's our basic matrix multiplication.
Yeah.
Go across the rows and the columns, multiply together, add it up. Let's write a little matrix and a little benchmark and try it out. And oh dear, 0.005 gigaflops. That's not great. How do we speed it up? Well, actually, believe it or not, we just take that code, we copy and paste it into a new cell without the %Python, And because Mojo is a superset of Python,
Oh, the percent Python literally runs Python. He did say gigaflops. Okay, personally, I prefer the Sigma flops, but some people, they're honestly not as, they're not really into the flops, so they don't know about that.
this runs too, but this time it runs in Mojo, not in Python. And immediately we get an 8.5 times speed up. Now, there's a lot of performance left on the table here, and to go faster, we're going to want a nice, fast, compact matrix type.
Okay.
Of course, we can use the one that Mojo provides for us, but just to show you that we can, here we've implemented it from scratch. So we're actually creating a struct here. So this is nice, compact in memory, and it's got the normal things we're used to.
Well, float 32s, okay. Probably should have chosen a better float, huh? Right? Isn't it, if you choose a float 32, what actually happens underneath the hood, isn't it like more instructions if you're running on a 64-bit? Forgive me if I'm ignorant on this one, but in my head, to do a 32-bit operation, you have to take your read line, right, and actually like bit mask out your data. If I'm correct. I don't know. I've only theorized it in my head. I haven't actually, I haven't actually tried. Is that true with floats? I don't even know. By the way, this text is unreadable. It's unreadable, and I have no idea what you're saying other than, yeah, I do look good. I agree. Dude, I totally agree. This mustache is wonderful.
Stuff you don't expect to see in Python, like alloc and
SIMD's
like SIMD.
nuts.
And as you can see, the whole thing fits in about a page of code, a screen of code. So that's our matrix. And so to use it, we copy and paste the code again, but this time just add a type annotation. These are matrices. And now it's a 300 times speed up. Suddenly things are looking pretty amazing. But there's a lot more we can do. We can look at doing, if our CPU supports it, say 8.
Oh damn, we're about to go full SIMD's nuts on them.
Elements at a time using SIMD instructions. It's a bit of a mess to do that manually. There's quite a bit of code, but we can do it manually.
I've always wanted to play with SIMD's nuts. You know what I mean? Like, I've always wanted to play with them. I've never actually got my hands around them, and I've never tried to do something. You know what I mean? Have any of you tried to play with them? Because that'd be great. That is like what I want in life right now. Maybe that's something we can do in Zig.
A 570 times speed up, but better still, we can just call vectorize. So just write a product operation, call vectorize, and it'll automatically handle it on SIMD for us with the same performance speed up. So that's going to be happening in the innermost loop. We're going to be using SIMD. And in the outermost
SIMD's
loop,
nuts.
What if we just call parallelize? This is something we can do, and now suddenly the rows are going to be done on separate cores for a 2,000 times speed up. So we've only got 4 cores going on here, so it's not huge.
How does parallelize work? Is this some sort of like lightweight green thread that just happens that does something that Rust literally could never do? Is this what Rust cannot do? No? Okay. No? Okay. Well, Rust really sucks that, like, if you have one buffer of memory and you want to write to it with a bunch of threads going super duper fast, but you know that your threads aren't going to stomp on each other, like, you can't really do that in Rust easily.
If you've got more cores, it'll be much bigger. This is something...
Okay, hold on. You tell me... Hold on. Then how does this run? You just told me this wasn't green threads, but it says it's running on these different cores. What is it running on? What is it doing here? I assume it's not spawning actual processes because actual processes are probably too big, right? You can do it with lifetimes in Rust? No, you cannot. Can you do that in Rust? Can you actually split? Really? I should try that. Huh. An actual OS thread? Oh, okay.
Absolutely can't do with Python. You can do some very, very basic parallel processing.
Okay. Hey, I'm glad to be wrong multiple times.
Creating separate processes and having to move memory around, and it's pretty nasty. And there's all kinds of complexities around the global interpreter lock and so forth as well. This is how easy it is in Mojo. And so suddenly we've got a 2,000 times faster matrix multiplication written from scratch. We can also make sure that we're using the cache really effectively by doing tiling, so doing a few bits of memory that's close to each other at a time and reusing them.
Oh, wow.
Tiling is as easy as creating this little tiling function and then calling it to tile our function. So now we've got something that is parallelized, tiled, and vectorized for a 2,170 times speed up over Python.
Tiling's new to me, okay? I understand 2 out of 3 of those words, which I feel pretty good about, because if you understand 2 out of 3, like, you can pass a lot of colleges. You know, D's earn degrees in some states, and so that's like, there's definitely a W there somewhere. You know what I mean?
We can also add unrolling for
Yeah, it's code. It's cache
2200 times
locality.
speed up. So vectorize unroll is already built into Mojo, so we don't even have to write that. Now, there's a lot of complexity here, though. Like, what tile size do we use? How many processors? What SIMD size? All this mess to worry about.
A lot of people struggle with their SIMD size. I get it. You know, a lot of us wish we could go bigger, but you know, there's limits to nature.
And each different person you deploy to is going to have different versions of these. They'll have different memory, they're going to have different CPUs, and so forth. No worries. Look at what you can do. We can create an auto-tuned version by simply calling auto-tune. So if we want an auto-tuned tile size, we just say, hey, Mojo, try these different tile sizes for us, figure out which one's the fastest, compile the fastest version for us, cache it for this individual computer, and then use that. Parallelized, tiled, unrolled, vectorized, for a 4,164 times speed up. So this is pretty remarkable, right? Now, it's not just linear algebra stuff. We can do really iterative stuff.
Did my man Kanye West just get into this? What the hell just happened right there? Oh my goodness.
Like calculating Mandelbrot. So we could create our own complex number type, and it's going to be a struct. So again, it's going to be compact in memory. It looks like absolutely standard Python, as you can see, multiplying, subtracting, using the operations. And to create the Mandelbrot kernel, we just take the classic Mandelbrot set equation,
Classic.
iterative
Everyone
equation,
knows about
and,
that.
Pop it in Python here.
Yep.
And then we can call it a bunch of times in a loop, returning at the appropriate time to compute the Mandelbrot set. That's all very well and good. Did it work? Well, it'd be nice to look at it. So how would you look at it? Well, it'd be nice to use matplotlib. Oh, no worries. Every single Python library works in Mojo. And you can import it. Check this out. Plot is import the Python module, matplotlib. NP is import the module, numpy. And the rest of it, this is actually Mojo code. But it's also Python code. And it works. And
I always hated Rust anyways, honestly. To tell you the truth, I never liked Rust. I think I've always thought Python was the best. You know, Python really is just the best, huh? Yeah, I think so too. I've always felt that way, and this obviously just confirms all the things I've been telling you guys for years at this point. And so, really happy about this. Really happy.
I don't know if you remember, but Chris actually said the Mandelbrot set is 35,000 times faster than Python. And that's because we can also do an even faster version where we're handling it with SIMD. And we can actually create the kind of iterative algorithm that you just
tile
can't
and tune
do
it? Can we
in
auto-tune
Python,
this?
even with the help of stuff like NumPy. This is something which is really unique to Mojo. So we now have something here which is incredibly flexible, incredibly fast, can utilize the hardware you have no matter what it is, and is really understandable to Python programmers like you and me. I think finally we're at a point where we are going to have something where I actually...
Hey, real talk though, that was very incredible watching that. Right, like that was really, really incredible. It was really incredible. You know, I like to dog. You know, me and all my homies hate Python. I get that, but that was really incredible. Like that, the fact that you can use all of the libraries that you normally can use with Python, or at least the ones that they showed. Now, whether it's true universally, whether there's some things that really suck about it, whether they're blah, 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 I get that. And it's relatively a fresh language. If they come up with a good package manager, a good build tool, some good linting, and then even I saw some type definitions in there. Like, long as you can throw all those things in there and you can really focus on that kind of like that developer integration. Notice I don't use the term of developer experience. Long as you can have those things and you go really hard on the LSP, you can make an exceptionally successful language, I think. I think that this has a lot of opportunity. But again, you know, what opportunity does it have beyond just machine learning? I don't know. Again, I don't know. I could see myself using this for all my visualizations, right? Because I have to do a lot of visualizations. I have to do a lot of that crap, you know, and it's really annoying to do all that crap. It would be really sweet if this just works. It'd also be sweet. Does Mojo produce an executable? Does it have a lot of cross compilation stuff? Is it easy to use, or is it still more like Python-y? Like, is it more interprety? I don't know. I would just like a faster Python. Apparently, this is just a faster Python. Anyways, this is super cool. Rock on. I like this. And now the Fireship version.
It is May 4th, 2023, and you are watching The Code Report. Python is a wonderful language for productive programming, but it has...
That's a good meme right there.
one big problem. It's too slow. And going slow means you'll get made fun of by the Rust and C++ chads of the world. But the tables are about to turn thanks to a brand new programming language called Mojo, a superset of Python that's not just 2 times faster, not 10 times faster, but up to 35,000 times faster than your...
Okay, well, I didn't mean to pause it right here, but I mean, that number should just hurt us a little bit, right? This should just hurt us a little bit. And now we do know that it is a superset, but it doesn't work with all the Pythons yet. But that should just hurt us a little bit, that this could even exist, that this is a real thing that happens in a real language.
Than your grandpa's Python. And that's a huge deal because Python's the dominant language for artificial intelligence, but behind the curtain...
Whoa, go back there. Why are those machines looking at the keyboard? Okay, you would expect the machines to not look at keyboards. Look at
because
this.
Because Python's the dominant language for artificial intelligence.
He just looked at the keyboard! No way. People, no way. No, this is, okay, you know what? Skynet can't happen if they have to look at a keyboard, okay? If robots literally come out and they go like this, you know, I spend more time thinking than actually typing, so being a good typer doesn't actually influence my programmer speed. I would literally realize that there's no possible way. Skynet can't actually exist. Robots are just as stupid as people.
But behind the curtain, anything that needs to go fast is written in C or C++.
Yep.
In today's video, we'll take Mojo for a spin, but first, here are 5 things that you need to know about it. 1, this is not some random guy's side project on GitHub, but rather it comes from a company founded by Chris Lattner, the guy who created the Swift programming language and the LLVM compiler toolchain. If anybody could fix Python's problems, it's him. And if you have no idea what LLVM is, check out this video. 2, it's a language designed for programming on AI hardware, like GPUs running CUDA and other accelerators. It achieves this by leveraging multi-level intermediate representation to scale to exotic hardware types without a...
Those are a lot of words, and when he says a lot of words at me like that, it makes me feel stupid. And when I feel stupid, I just feel like attacking him. So Fireship. You know, here's the deal, Fireship, okay? First off, Fireship, you know, earlier on Twitter, when you asked what should my next video be, I kindly reported a video and you said the top liked one will win. Well, guess what? I did that and you didn't make a video. So now I'm giving you another response right here. Again, for you to make it, please make a WinRAR video, okay? I'm still waiting on WinRAR. I want you to make WinRAR. And second, I'm going to be back in Arizona if you want to, you know, grab dinner again. Just wondering.
Ton of complexity, and it even has built-in auto-tuning to optimize your code for your target hardware. 3, it's designed...
Yeah, that auto-tune thing was crazy. It was the craziest thing I've ever seen in my lifetime, that you can just be like auto-tune. And how does it make that decision at compile time? Is there some sort of like reading speed that's related to the hardware you're on, so thus it's able to make a good decision? Why do you even have to you know, put what sizes you want?
As a superset of Python, in the same way TypeScript is a superset of JavaScript, so you don't need to...
I am almost ratioing DHH, yeah. He didn't respond because he is a coward. You know, here's the deal. If you make a tweet and it gets 1,000 likes and someone asks you a question and it gets 1 like, you're probably not going to see it. Real talk, not trying to be mean. That's just how it works. But if you make a tweet that gets 1,000 likes and someone's reply to you gets 800 likes, you saw it. You read it and you didn't respond because you're a coward.
Learn another language to take advantage of it. And this is unique compared to other modern systems languages like Rust, Zig, Nim, and so on, which would have a higher learning curve for existing Python programmers. It does have a bunch of features on top of Python, like var and let declarations and structs, but the base language is fully compatible with Python.
Okay.
And it can also...
Is that how it does the speed up? I didn't see that. I didn't see the struct part. Is that how they're doing part of the speed up, is that they're not doing Python crazy classes, but instead they're just doing like... structs underneath the hood. And yes, I believe Mojo will finally be able to tell me how big my dick is in bytes in Python. I believe it. I truly believe it.
Interop with the Python ecosystem, which means you can still use your favorite libraries like NumPy, Pandas, etc. 4, it adds strong type checking to the language. You can still use dynamic types if you prefer, but static types are essential for optimized performance and error checking. For memory management,
I actually think that's one of the coolest things ever. To me, that's like what makes this so, you know, because I I'm not going to learn Mojo. Real talk, I'm not going to learn Mojo. But something that makes me really excited about Mojo is the fact that types have implications in how the thing runs. Whereas in TypeScript, it doesn't. The only thing it accidentally gives you is monomorphic optimizations, right? You define your in type by putting types on it, and you'll accidentally only call a function with a specific set of types, right? So you'll accidentally JIT it, but this thing actually being able to be like, oh, it only takes in this one type, well, we can make it special for this. That's super cool.
It has an ownership system and borrow checker similar to Rust, and also supports manual memory management with pointers.
It has a borrow checker and ownership, but is it shitty like Rust, or is it actually like super fast?
Like C++. It's a pragmatic language that gives you safety, but also the flexibility to be unsafe when needed. Now, the final thing to know is that currently it's not available to the public. It's still in very early development.
Wait, hold on. Are you telling me we just got done watching multiple videos about a language I can't even use? All right, Mr. Latner, with your big claims on performance, your big claims on all these things, and yet you showed us a for loop, which we all know is the slowest in Python. You make these claims of millions of percents faster, yet we can't even look at it. Right now, Mojo's kind of like vaporware to me, okay? I want you to know that right now.
Development. It will be open sourced in the future, but currently there's a waitlist to try it out. I was lucky enough to get early access, so let's fire it up. To run it, you can create a file ending in .mojo or .fire emoji. That's a huge advantage over Python, which doesn't allow you to name your files in .snake, but we can also run the code in a Jupyter notebook, where it behaves like an interpreted language. Here we have a matrix multiplication demo that computes a dot product to demonstrate the crazy performance gains we get with Mojo. First, it benchmarks a basic function in Python.
I do say that this feels like a cheating version. You found the worst case thing that Python does, which is loops. And then by literally choosing the worst possible answer, which is loops, I do feel like it's a little, like this test is a little weak.
Python. Then by simply importing that code into Mojo, it's executed 14 times faster with no modifications to the code.
It was actually 8 times faster if you remember the previous video, Fireship, which you didn't remember the previous video, okay? Okay, we all remember this part where he jumps in here.
But instead of telling you...
But this notebook is no normal notebook. This is
to run our own, but we're just showing
a little make
go.
Without the percent Python. Nice, fast, compact.
8.59 times faster, okay? Some of us were paying attention to Mr. Latner, or whoever that person was that was speaking. Jeremy Howard. All right, Mr. Fireship.
But we're only just getting started. We can further optimize this code by adding types to the Python implementation. Mojo allows us to do that with its built-in struct keyword. A struct is very similar to a Python class, but structs are static, unlike classes which are dynamic. Inside the struct, we also have keywords like var and let, which can define mutable and immutable variables, and def is replaced.
Can we just stop with var, let, and const being different in every language? Like, this language, var obviously means change. Let means no change. In TypeScript, let means change. And const means you can still change it. It's okay. We're TypeScript. We love you very much. Go ahead and do it. And in Rust, you got let and let mute. This whole thing is just it's really frustrating.
With fn, which is a stricter type of function. Also notice single instruction multiple data, which is a built-in type that represents a vector where a single instruction can be executed across multiple elements in parallel on the underlying hardware. Once we have this struct, we can then use it as a type in the Python implementation. Then when we benchmark the code again, we get a ridiculous 500x performance boost, but we're still not happy yet. In the inner loop, we can query the vector width instead of hard coding it, and that gives us a 1000x gain.
I feel like
but that's nothing compared to what we're about to do. Linear algebra is perfect for parallel computing, and we can easily make our code multi-threaded with the built-in parallelize function, increasing our speed buff.
I'm not gonna lie to you, this version of this code is like 10 times better than the previous version. The previous one, he went really into detail. This is the speed in which I want to get hit with information, okay? I wanted high speed.
2000x, but now I've got a fever, and the only prescription is more performance. Luckily, Mojo has built-in tiling utilities that basically allow us to cache and reuse data more efficiently, and we can even auto-tune it to find the optimal parameters for our hardware. The end result is over 4,000 times faster execution compared to the original Python code. That's pretty crazy, and if you want to see this code broken down in greater detail, I'd highly recommend this video from Jeremy Howard. But I'm curious what you guys think. Do you really think Mojo could kill Python and C++ at the same time? I'm a bit skeptical, but employers are already hiring Mojo developers with 10 years of experience. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Like and subscribe, please. Like and subscribe. I'm subscribed to my other channel. Hey, look at that. Hey, that's me. I feel like this
Brain
is... Got him.